now we can actually talk about Python. Yay, Python, right? So I actually am not going to talk about that one because that one's not completed. But our coding best practices, as I mentioned before, this is when you guys already have some practice in Python itself, PEP 8. So I would highly suggest reading this. The Google style guide is actually really great to actually go through. It describes a lot of like examples of what's going through. No, this is their style guide. If you follow a style guide, you're already in better shape than most people who start off in data science. Most data scientists, their critiques are usually that their code is really unreadable and I can't understand what's going on. It's not documented. So if you're just aware of that, you're probably better than like 50% of data scientists starting off. Because not all data scientists start off as like coders to begin with. But these are some basic good practices that are part of PEP 8, but also just general that will help you out too. There's this thing called readability, where basically don't put magic numbers. And when I say magic numbers, is that like, if you know the length of a array or a list is like 40 long, you don't just put in like range of 40, you actually use that variable in there. So the thing is basically when you see things like a magic number would be something like, all right, I have this, list right here. This L is equal to, let's say 1, 2, 3, 4, 5. So you can see here, how long is this list? 1, 2, 3, 4, 5. Okay, so I could do something like for I in range of 5. I'm actually gonna put a 0 here, make it nice and easy for us to go through. No, that's fine. All right, so I in range of 5, and I'll say, okay, print Li. So hopefully this is all familiar to you guys, nothing too crazy that you guys haven't seen from the prelim. So what this will do is basically a range of 5. Does anyone know what range of 5 will print out by itself? Like if I just did range of 5 like this. Yeah, so basically it's going to print out this thing. I could also convert this into a list, make it a little bit easier. This is called typecasting. So basically it says in Python, hey, take whatever's in here and convert it into a list. And you can see here, it's just basically the numbers 0, 1, 2, 3, 4, 5. So if I literally just took this and replaced it with here, it would do the same thing, okay? So what this is gonna do is basically say, all right, get the number 0 first, and then afterwards gonna do some stuff. Go ahead and say, get number 1, get the number 2, get the number 3, and do stuff with it. So the first one's gonna pull out is the number 0, and it's to say, okay, for L0. So if I actually did L0, what would this print out? 1, good. See the fingers, right? So you can see, oh, well, I didn't define it first. Let me go ahead and define this. There we go. So I do L0, you can see prints up number 1. If I do L bracket 1, what would that print out? 2, right? Good. You guys get the point. So this one right here will go from the first 0 will be 1, and then the next one will print 2, and then 3, 4, 5, right? Cool, works fine. This is perfectly legit code. It is not very readable because let's say I have a bunch of other code down here, right? Like a bunch of other code, writing through, and then later on I say for I in a range of 5, L equals I1. If someone didn't write this code, you might say, why 5? What is going on here? And you might say, oh, it's because there's 5 elements in this list over here. That's why I have 5. This technically works, but there's some issues. What are some issues we might come across?
If you have a new list with more numbers.
Yeah, so let's say I make this list like, oh, you know what? I want to count actually all the way to 10, right? Problem is now, if I expected this to print out my whole list, it'll still print out this guy. So it's like, oh, well, that's not good. So we want to make this more generalizable, right? It's also maybe not as readable, right? So for example, it's like, why is this 5 here? It's a magic number. It's just a 5. We don't know why it's there. So one thing you could do, for example, is like, oh, like you could do length of L and say equal to 5, and then you could do like this, right? So this helps a little bit because now it's like, oh, okay, this is the length of L. Okay, cool, that makes sense. But as Lauren said, you probably still have an issue here, right? Because now if this list gets bigger, you're gonna have to, oh yeah, I have to change this part out too and everything like that. Oh, if I added like another one in here, that's gonna be an issue. So how can we more generalize this to something?
Length function, well, yeah, length function.
Length function, right? So length function represented with len. Thank you, Melvin. And then we can just do L right here. And this will tell the length of L, right? How big this is, and that will be the length of L. And so, for example, if I just go ahead and put, I'm being very robust here, you can see 11, which is what we'd expect, right? Length of 11. And so if you do this now, it'll print out all 11. Cool. In fact, this is probably even more redundant than it needs to be. You could probably just replace this with this part right here. And then it's really obvious, oh, okay, you're going to get the range of the length of L. That's just going to be a number. It's going to be a range of this part. So this is a little bit easier to like understand. It's relatively short, and you don't have to worry about like what is the actual meaning of these things. Okay, so that's what readability is and what I mean by no magic numbers. Cool. Any questions about this, General? Sound good? Cool. All right, and then some thing. Oh yeah, go ahead.
I just have one question, and I don't want to kind of stir the pot, but isn't it supposed to be good practice to not use a lowercase l by itself as a variable?
Very good.
Okay.
And that's exactly what I'm about to talk about too. So good catch. Yeah, this is not a good practice. A lot of people write code, especially I will say is a lot of people who are more mathematics. Like there's a lot of people, like I was this way too, is that who come from some mathematical background who are not from data science, not computer science, even computer scientists, they'll use like lowercase letters all the time. One thing you can't, oh, I just got it deleted, but one thing you can do that's more accepted is like for a looping stuff where it's a temporary variable. This is kind of common practice. Sometimes it makes more sense for you to put another word there instead. For example, if you're looping it over, let's say student names, you might put, for example, let's say instead of L, you put student, names like this. I might put like, okay, like I might put like name here for that L, right? For student names. And so this is a little more readable. It's like, okay, I'm getting the name for everything that's in student names. And this is what you want to do with part of readability is make your variables associated with what you're doing. It's best not to have like a lowercase stuff. This kind of, I mean, just a single lowercase letter. It should be descriptive enough where someone can understand it. You'll tend to see me write very long variable names, and we use, is classically used in Python. We use all lowercase for variables, and then we use snake case, where basically use these underscores as spaces. If you might be familiar with something called camel case, okay, this can also be used. They're both valid, but this tends to be used in Python. I like to use it too because it's really readable and easy to read. And you'll see most things written out like this too. Okay? But just notice a difference. For classes, which we'll talk about in the future, but for classes, we use something like a capital variable like this. So a class name right here. And so this signifies, it's still perfectly valid. Like I did class name equals 1. This is not a class. I know you guys don't know what a class is necessarily right now, but this would work perfectly fine. It's just that by convention, we'll keep capitals for classes. Constants, if there's a specific constant, like a good old constant might be like pi, for example, right? So we tend to use capital letters, and that way it's a little bit easier to understand, like, oh, that is a constant that we care about. There's a special kind of thing that you can do in Python that doesn't seem like it makes sense. But you can start your variables with an underscore. And usually this signal right here with this underscore, you'll see this a lot, is basically it signals to the coder, the person programming, that this is supposed to be an internal use variable. So it's not supposed to be something that other people will reference it. This is kind of like, you're like, what do you mean internal use? This will become more familiar with object-oriented programming, where we'll use an underscore to signal, say, oh, this is something that you shouldn't have to worry about. It's more like something that's like, it's going in the back end, but there'll be something else that we reproduce. So for the most part, if you have an underscore, if you're trying to say, this is not going to be used for the average, coder who imports your code and stuff like that. It's more like internal use. And we'll see more examples of this in the future. Okay. And then of course, use meaningful variables. Similar to what Jeffrey had said, you don't want to just have like a single letter. You want to use something that's descriptive of whatever you're actually doing. Okay, cool. And then a good thing to do, especially in data science, we'll tend to have like, the words average and mean and stuff like this. It's a good thing, for example, if you have like, like student grades average or something like that. Like it's good to end it with like that phrase. That way you can very quickly see, oh, it's the student's grades, it's the average. This obviously is everyone's style. Some people might do like something like average like this. Okay, you might see me really quickly write just average sometimes. this tends to not be good form, because then, average of what? It could be anything, right? And this is something where I like to say, you're not just writing for code. This is important when you're writing code for other people, so other people can use it and read it. But also, I like to say, if you're writing code for yourself, you're not writing for, and not just for yourself, but your future self. There's so many times where you come across code and you're just like, oh, I wrote this like a month ago. And you're like, what was I doing? Like, you can't remember exactly what's going on. And that happens, I mean, maybe more frequently to other people than others. It happens to me all the time. I'm like, write code the next day. And then the next day I'm like, what was Victor doing? Like, I don't understand. So I'll write comments and stuff like this. So making sure variables are good names, but also writing comments explaining, like, oh, like the average, what this is, or why you did it this specific way. This is where you can like do explanations, since comments aren't run in the code. I like to say is that when you're doing your programming, especially a more complicated program, is to actually use comments to explain your thought process. So I might say like, okay, like, read in data for student names. I might say, okay, like for each student name, capitalize. Can't stop capitalize. All right. And then I would say, okay, like, and then say, search for grade by student name. So I didn't write any code yet, but at least then like I can see like what conceptually should I be doing. And this is helpful because then all I have to do is like, okay, we'll read in student names. I'll write the code to read in student name. So for example, in Pandas, we'll be like read CSV, okay, get this part in there. And then I'll write the code for this for loop here. I'll say, okay, for name and students, something like this. I'm just writing random code, dot, title. So like, I might do something like this, like, okay, like this is where I can get an idea of what's going on. And so one, it instructs me what to do, but what's really nice, and this is my key secret, is that it's already documented then. I don't have to go back and start commenting stuff over here. It's already commented for the most part for me. And this is kind of like a nice little shortcut. So you don't have to like write this whole big project and you're like, oh, cool, I'm all done. You're like, oh, I should document this. Because in reality, you're gonna be like, no, I'm not going to document this. It's going to take too much work. I already did all the work. So this is my suggestion. And it also helps you figure out conceptual issues. If you're like trying to code something up, you're like, oh, wait, I missed this step. And you can go back into that. Okay. That's a little segue, but I think it's an important one. All right. And then functions. So hopefully we all know what functions look like at this point. I think they talk about them in section 3. I think you should have used them in the prelim. Is that right? Functions, yeah. Okay, so we always start a function with def, right? And we give it function names. Function names are still applicable to like variable names, so we usually do lowercase. So for example, I might say like, let's say capital. And so this function already exists, but I say, oh, capitalized word. I can give it a parameter, right? So I can say like, oh, capitalized word, give it the name word, right? This is basically so you don't have to repeat yourself over and over again. So if you find yourself basically like copying over and over and over the same process, it might make more sense to do a function and then use that function, call it over each time. So for example, let's say capitalize middle of word. Okay, I might do something like, okay, let me do word, and I'll say, okay, let me get like the middle of it. I'll just say like the first one, just say, or I'll say second letter. And you'll see my function's going to be a little long names. But you can see here's my word. I'm going to say, okay, capitalize the second one in there. So I say, okay, let's do word dot title. So this will capitalize the actual letter. So I say, let's say like second letter. There's a bunch of ways you can do this. I'm doing like a really brute force way. So I can say, okay, word 0 plus second letter plus word, and this is like the second, the third letter, and then onward, right? So that's what that colon means, basically, go to the very end. So that will be my new word, so I'll call it like new word. And I'll say new, return new word. Okay, so that's my function, right? So the reason why I might want to write this is because instead of, for example, if I had like a bunch of words, for example, I have like hello, I don't know, what's some other words we got? Victor, security. I am not very creative on the fly, right? So the point is that you have all these words, and I might say, for example, I might do each one. I have to write, okay, hello, and say, okay, dot title, and like write these parts each time. Instead, what I can do is like, okay, well, let me just do capitalize second letter of the word. So I'm copying this, and I'm about to show you guys some really cool trick with Jupyter Notebook. So I have to like paste this in here each time. I can actually, if I do command click on each line, I actually make a new cursor on each part. If you have Windows, I believe it's control click, but I can just now paste that directly on here. I can now put a parentheses. I can go ahead and go to the end of the line, do that. And that way I can kind of edit multiple parts. But now you can see I just capitalize each second letter of word. I can go like this. I run it through. Oh, well, I didn't print out each one. So if I go now, print, you can see here, it all works through. Even this is probably more robust than it needs to be. For example, one way we could have done this is we could have made a list of words, so like words is equal to, I'm gonna go ahead and copy all this. So I'm making all the parentheses like this. I'll make it into a list. Okay. Oops. It's being too smart for me. Okay. I have words as a list, for example, and then I can just say for word in words, print, was it capitalize? Second letter of the word, of word. Okay. And you can see I do the same thing. Well, I already did this part, so. So this might be a little more robust. The reason why I might want to do this is because now I just add another word on here. It'll be easy, right? So I can just add this onto here. Okay. Yeah. So, oops, I didn't put a comma there. There we go. So yeah, that's kind of like why you would use these functions. Do this often, get in good practice of doing this. That way you can reuse these parts in here. It's also good to say what it'll do. This is capitalizing the second letter of the word. I didn't just put capitalize, or I didn't even put like capital, like, or whatever function you want to do. It's good to describe it. So now I can say, oh, what's this function do? It capitalize second letter of word. Oh, okay. That's pretty easy to understand. Okay. It's also, so use instead of hard code in relationships. So again, it's better than just doing this by hand. It's good to actually say, okay, let me feed this function in, do something with it, and do stuff with there. Okay. Any questions on these functions, like good practices? And you got to see a little Python or like how you might approach this. Okay. Security. This one is, again, we'll talk more about this when we do APIs, but don't hard code your passwords. Don't hard code, usernames up maybe, but like, be careful of anything that's personal identification, especially when you're dealing with data. Be very careful about what you print out. If you do a save here and commit, this printout, it won't just save your code, it will also save this printout here too. So be aware of that when you do a commit. So one thing you might want to do is do like a kernel, sorry everyone. Like restart and clear output. So I might do like clear output. So that way nothing's on here. And that way you can save it from here and do that. So that's important, especially if you're doing personal information, if you're reading a database or a CSV file and it's coming out through and you find out, you're like, oh, like they're printing out some people's passwords or social security numbers, which yes, social security numbers get passed around like crazy with data. For good or for bad, right? But the important part is that you could accidentally leak the stuff, especially when you upload it to GitHub. One important thing about GitHub and Git in general is that if you make a mistake, if you put out personal information and then push it out there, you're like, oh no, I made a mistake, let me delete it, delete it and then do that push. The problem is because GitHub or Git keeps all your changes, that change of your password can still be in there. So you have to be aware that on this. And I guarantee there are people online who look through public GitHub repos looking to see if there's any leaked passwords or information and stuff like that. So be super aware of this. We'll talk about how to, also when you have like an API key, it's kind of like a secret long password that's generated for you. And with that API key, you can basically do whatever you, like not do whatever, but basically that identifies you with a service. We'll talk about what APIs are, but the important part is like don't hard code your API key directly on your notebook. There's ways we can basically put that out of our notebook and we can keep saving and pushing it out without having to do this. So you might do something called an import. So this you've probably seen like from import for Python or Numpy and Pandas and stuff like that. That's kind of like what you would do here. And this is something that we'll talk about again when we get into, I believe, module 2 when we talk about APIs and such. Okay. So there's some good best practices. You guys got to see a little more Python code actually, versus me just talking about Git in terminal. Hopefully that makes you guys feel a little bit better. But any questions about anything I kind of went over or talked about for this stuff? I'm pretty good. Cool. All right, awesome. So we have a few minutes, or like 3 minutes left, so I'm not going to go into it right now, but I'll show you a little bit of Numpy. So first of all, give me a thumbs up if you're on section 3. Okay, cool. So if you're on section 3, awesome. I think that's when we actually introduced NumPy and such like this. So we won't go through this whole thing right now. Basically, just know that NumPy and then also Pandas, which I love the connection between these two, so we'll talk about that. But NumPy and Pandas, they are different modules, and the way you can think of this is like they're other code that other people had written, and you're importing this now into your code, so you don't have to rewrite it. It's kind of like if I wrote a function, I don't have to rewrite the function every single time to perform it. It's the same thing as that basically someone created a whole bunch of functions, a whole bunch of things for us to use, and instead of you having to recreate that all yourself, you have to just simply import it and can use that. And so note on these imports, you have this import NumPy, and usually we do import NumPy as NP, import Pandas as PD. Those are just common conventions. You'll see people use them over and over again. We also could have simply used, like, if I got rid of this part, you could have just imported it like this. And this tends not to be common practice, because in order to reference any of the functions that are built now into NumPy, I have to do numpy.array. And I'll do, like, let's say, oops, like this. So now I have an array here, but I have to do that whole NumPy thing. So usually we'll actually import as NP, because then what happens, I can go ahead and just put NP here and go through here. One thing you will see on code, and I'm going to suggest don't do this. It's fine to practice this. People will say, like, they'll do it like this. They'll do from NumPy, from NumPy import. They'll do something like this sometimes, which is fine. And that basically means that if you do this part, it means you can just do array like this, and you don't have to worry about doing this. This can be trouble, because if you now have another variable that's called array, it will overwrite it and stuff like this. One common example of this, if you do print equals 2, we know print is a function, right? But all right, let's just do print equals 2, right? Python doesn't care. Python's like, all right, cool. So the problem is now if I do print later on, if I do print 5, this should print out the number 5, right? You'll see an error. It's like, hey, what's going on? And it's because this now is a variable. And so Python's very flexible and not let you do this. So one thing you can do is, like, if you already have a variable called array, so you can see how, like, my array works here. If I now say array equals 2, and if I try now doing array, you can see again an error here. So this is why, like, you might want to be careful about importing this specifically. Usually we import the actual name, so we can do NP. One thing you'll see a lot of though online is this. Don't do this. There's no reason to do this. And what this star means is that wildcard. Basically, it means from NumPy import everything. There's a few reasons why you don't want to do this. Because remember how I said, like, you can overwrite the function? You can also have those things overwrite other functions too. And you don't know if it came from NumPy or if it came from Python or for something you wrote. It's really hard to debug and hard to realize that's going through. So the safest is either going import, like, the actual module like this. The next part, which most people do, will be import like NumPy as NP. And then the third part that you can do that's also common, you would say from NumPy import, and then you might say the specific function. Though just be very careful with this, because if this name is really common, you might overwrite it or something like this. So usually the safest one is one of these two, either this one or that one.